Alright, guys. This is the purple sheet. It just doesn't look purple because of my light, okay? Alright, so here is does everybody have one?
Yeah.
Here's the quadrilateral family tree. Okay, so remember, it all starts off with a quadrilateral. So all of these things underneath the quadrilateral are quadrilaterals. Basically, this is like a last name. You know how like you might have siblings that are your family, and most of you, now this isn't for everybody, but some people have same last names, right? But then your first name is different because you're different people, but you're from the same family. These are all quadrilaterals, but they're different forms of quadrilaterals. So we've already talked about parallelogram. So check. We've learned about that one. Our next one is to learn about rectangles. You're about to learn more about rectangles than you ever thought was possible. And it's going to be fun.
That sounds like the title of the worst movie.
Okay, so underneath rectangle, draw a rectangle. Now remember, y'all don't be mean to me. My rectangles aren't always the cream of the crop.
What's easier than parallelogram?
I'll let you be the judge of that. Okay, so we have a rectangle. Here are the properties of rectangles. Okay, this side is the same as this side. So good so far, right?
Yep.
This side is the same as this side. Okay, now one difference between a parallelogram and a rectangle is that all of these angles are 90 degrees. That's the main difference. There's two main differences. One is that they're 90 degrees. Okay, now draw your diagonals because this would be too easy without diagonals. Oh man, I can never draw them good.
Good job.
Okay.
You did that one.
Here is the second main difference. Remember, in a parallelogram, this is congruent to this, and this is congruent to this, but they're different.
Yep.
4, 4, 5, and 5. Okay? Now, in a rectangle, whatever this one is, all of them are the same.
Oh.
So whatever one half of this is, let's say 6. If this is 6, then this is 6, this is 6, this is 6. Which means the whole diagonals are all equal to what? Whole. 12. 12 and 12. Okay? So we're going to keep this. But now, let's go to our 6.4 note taker. And let's do the same thing. Practice makes perfect. Okay? So let's use these characteristics and make sure we didn't miss anything. All 4 angles are right. Okay? So let's draw little squares. I just want to make sure we check all the characteristics off. Okay? Opposite sides are parallel and congruent. Now, here's the thing. Listen carefully. Isn't on our family tree, a rectangle's under a parallelogram, right?
Yeah.
And one of the properties of parallelograms is that all the sides are parallel to each other. So as long as you know that, I don't usually draw the parallel because it gets too cluttered. You know what I mean? So know this. Don't forget that they're parallel, but I'm not going to necessarily make you draw them every time. So let's draw our congruents. So this is congruent to this. Congruent, congruent. So check. Opposite angles are congruent. Well, duh, right? Do we have to draw that? We know if they're all 90, then 90 is equal to 90. Okay. Consecutive angles are supplementary. Well, if all of them are 90, then any two add up to be what?
180.
180. Okay, but do we have to draw that? Like, we know that, right? Okay. Diagonals bisect each other. So let's draw our diagonals. Try to draw them better than mine. I'm terrible. I can't wait till we're at the new school and I have that screen and all I have to do is like draw, and then it'll fix my line. It's going to be amazing. Yeah, like if I, like this line right here, how it's crooked, if I would have drawn that on the computer screen, all I would have had to do is tap a button and it would straighten it out. Okay, now, all of these are congruent. Not too bad, right? Okay, now let's take everything we just learned and let's practice it. So example 1. Here's quadrilateral RUTS. It's a rectangle. It says above, but it's actually beside it. If US, so this whole diagonal is 6x plus 3, and this whole diagonal is 7x minus 2. Well, what do we know about this whole thing, US and TR?
They equal each other.
They equal each other. Yeah. So what would I do to these two?
Set them equal.
Yes, and solve for x. Good job. So you do 6x plus 3 equals 7x minus 2.
X equals 1.
So would you subtract 6x? Some people might do this differently. So you would have 3 equals 1x minus 2. Well, then you have to add 2. So x is equal to 5. Is that all it asks us to do? Dunzo. Okay. Next, this is another rectangle. If the measure of STR. Now let's remember, guys, how to figure out which angle this is. STR. So T's in the middle. STR. So it's talking about this angle right here. Is 8x plus 3. And UTR, which is this angle right here, is 16x minus 9. Find this one angle. Well, what do these both have to equal? 90. So wouldn't we add them up instead of equal to 90? Because in a rectangle, all of these are all right, which means they're 90. So you'd have 8x plus 3 plus 16x minus 9 equals 90. Remember, when you're combining like terms, you just do the sign that's in front. So 8 plus 16, 3 minus 9. So you would add 6 over. 24x equals 96. Divide by 24. You get 4. But is that our final answer? It says to find the measure of angle STR, which is this one. So plug it in, plug it in. 8 times 4 plus 3. What is it? 85? 35? What? Why? What is it that you hate about 3? I'm just glad you recognize it.
No, chill.
What is it? Y'all are looking at 3 and you're saying, please don't do 3. But what is it in 3 that y'all don't like? If this is 6, and FH, this whole thing is 15. And I want to find GJ. Yeah. So if the whole thing's 15, it bisects it, so this is 7.5, right? And this is 7.5. Well, whatever this is, all of them are the same. So GJ is just, yes. Do I need to explain that again?
No.
Take half of 15, and all 4 of these insides are just half of 15. 7.5 what? Don't forget your units. I'll be honest, I thought we were about to have to use Pythagorean theorem. Y'all don't remember Pythagorean theorem? A squared plus B squared equals C squared. Okay, last example, and then you're going to get to practice. if the measure of BEA is 62. Okay, so remember when we had puzzles basically and we had to find all the angle measures? Okay, so BEA is 62. And we want to find BAC. Okay, so let me explain. Is it true, hold on, is it true that all four of these inside angles are the same? Not angles, diagonals.
Yes.
Okay, remember, I'm going to just draw this out right here. Whoops, that's bad. Remember, when we have an isosceles triangle, I'm going to draw it again because that wasn't big enough. Remember when you have isosceles, when this is the same as this, we learned that if you have two sides that are the same, the two angles across from it have to also be the same. So in this case, I know that this is 62. Well, how many degrees is a triangle equal? And I know 62 of those degrees are taken, so 180 minus 62 tells me I have 118 degrees left. But I have to split that how many ways? 2. So the measure of angle BAC is what? Okay. Go back. Oh. Okay, if you flip to the back, you have 1 through 12. You also have 25 minutes. So, yes, you are going to do all 1 through 12. Okay, I'm going to be walking around helping you. Make sure that we're working on this in class, okay?